Welcome to another session of Maths Fanatics 24/7. On 3.1, they want us to consider the following progression. 3, let's use a different color. So 3, 1 over 2, I have another 3, 4 over 10, I have another 3, 16 over 50. Right. So I'm sure all of you can tell that this term here will be 3, right? Because 3 always, so there's 3, then there's a new term, then there's 3, then there's a new term, then there's 3, then there's a new term, then there's 3. Do you see? Then there should be a new term here. Perfect. Let's check the pattern that is happening in these terms, right? This one, that one, and that one. At the top, I have 1, I have 4, I have 16. So let's see. How do I obtain 4 from 1? I can either be adding a 3 or multiplying a 4. Right, so here I'm going to try to add a 3 to see if I can get a 16, of which I don't get. 4 plus 3, it's 7, so the 3 is out. So I'm going to use the multiplication now. So 1 times 4 is 4. And then 4 times 4 is 16. So obviously here I must have 16 times 4, which is 64. And then at the bottom, I must have, okay, let's check at the bottom. From 2 to 10, there are 2 ways to get there, right? It's either I'm going to add an 8. Okay, let's try. 2 plus 8 is 10. Now let's see if when we add 8, we're going to get 50. No, 10 plus 8 is 16. So we are not adding here. Let's see if I multiply. 2 times 5, I get 10, right? And 10 times 5 gives me 50. So I can conclude that, therefore, I'm going to be multiplying the bottom as well. So to get the bottom there, the denominator, I have to multiply 50 by 5, which gives me 250. Perfect. And then the first question, they say, write down the next 2 terms of the progression. So your answer will be 3. And then you'll have also 64 over 250. Then that's finito. Right. On 3.1.2, they say calculate the sum of the first 35 terms. Okay. So ladies and gentlemen, we will need to analyze this question a little bit, right? Let me just erase it. Awesome. So we have, I'm sure, let's go back and analyze that. Ne? I'm sure we can see that the 3 are occupying the odd positions. By odd position, I mean term 1, term 3, because term 3 is 3, and term 5. And then it's going to be term 7, and so on and so on. They say 35 terms. So 35 is an odd number, which means also term number 35 will be occupied by a 3, right? Perfect. And then even positions are occupied by this pattern here. This is term 2. And then term what? Term 4. This is on position 6. This will proceed like that up until term 34, right? Perfect. The reason why I'm splitting them is because here I have 2 types of patterns, right? The first pattern is just 3, 3, 3, 3. The second pattern is geometric. Why do I say geometric? Is because we are multiplying the top by 4 and the bottom by 5, which means our constant ratio is 4 divided by 5 because we multiplying the top by 4 and the bottom by 5 to get the next 10. I'm sure that makes sense. Awesome. So now we need to just calculate how many terms are here, right? Awesome. So ladies and gentlemen, from 1 to 35 in odd numbers, we can all agree that this is going to be 18 terms, right? Then these ones here are going to be 17 terms. Ne? So the total is 35, right? When you add them, right? Remember, this is how I got it. Ne? I said 35, okay. The one that is closer to 35, that is part of the pattern, is position what? is position 34, which is an even number. Because I have two patterns, I divided it by 2, right? So I'm getting 17 odd, 17 even. But the number that follows, which is 35, it also goes there. So I'm going to have 18 of that, and then 17 of that. Does it make sense? Perfect. So the sum of 3s, it's easy. I have 3 multiplied by 18 because there are 18 3s in the pattern up to 35, 10. Perfect. So there I'll get my answer quickly. Let's see how much we get. See how much we get. So we have 3 multiplied by 18, right? Which gives us 54. So this gives us 54. Then we're going to leave it there. And then remember I said the other pattern is geometric. This one, T2. And then that. And then that. And then that. Ne? If you have time, you want to prove it, you can prove this. Ne? You can prove that T2 over T1, you get the answer. You check T3 over T2, you check the answer. The answers are all going to give you 4 over 5. 4 over 5. Because we said we multiply the top by 4 and the bottom by 5. You can just substitute and punch on a calculator just to verify. Ne? Awesome. So on this geometric pattern, my first term, it's A, remember, which is half. And then my R, we agreed that it's 4 over 5. And then my number of terms, it's what? It's 17 terms. So I can easily get the sum, right? Remember the sum formula for geometric, it's Sn equals to A open bracket R minus 1 all over R minus 1, right? And then we substitute here. My first term is half. Let's do this to have space. I'm going to close the calculator. Let's close the calculator to create space. Perfect. So I'm going to move this pattern here. No? So S17, because N is 17, right? So sum of 17 terms equals to my A is half. My R is 4 over 5 in bracket. So here, let me put a square bracket then. To the power N, my N is 17, then minus 1. All over. My R is what? It's 4 over 5 minus 1. So let's punch this in a calculator, right? So I'm going to do this, and then I have half, which is just 0.5 basically. And then I have 2 brackets opened. I have 4 over 5 to the exponent of 17. And then minus 1. Then I'm closing the bracket. And then I'm dividing by 4 over 5 minus 1, which gives me 2.44, right? 2.44. Right. Therefore, the sum of 35 terms is going to be this sum plus that sum, right? It'll be 54 plus 2.44, which is 56.44, right? And then that should be your final answer for that question. Okay. Now let's go to 3.2. So on 3.2, they say calculate. Right. Okay. So ladies and gentlemen, when I see this symbol, sigma, right? In my mind, I'm thinking of sum. Ne? Sigma means sum. So it's either is going to be sum of arithmetic or geometric. Ne? In this case, because the n is on the exponent, I know this is geometric. Always when your variable is the exponent, you have a geometric number pattern. Okay, so if I have geometric, I'm going to check. Remember, geometric has 2 formulas. It's either Sn equals to ARN minus 1 r minus 1, or sum to infinity equals to a over 1 minus r. Ne? Those are your two formulas. But the sigma will tell you which one they need. Ne? You always check this part here. If they have n or they have a normal number like 100, 200, it means they're looking for this one. Ne? But if they have the infinity sign, it means they're looking for the sum to infinity. So for us to do the sum to infinity, we firstly need to get a and r. Ne? Perfect. So I'll show you how to get a and r. Ne? So for geometric, let me use a different color. So this number here, right? When you substitute it there, it always gives you the a. The number at the bottom, it does not always to be 1. It can be anything. But you should know that when you substitute it into here, your a is going to be that answer. So for example, here a equals to 5, 3, and then 1, I'm going to substitute the 3 where the n is. So it's going to be minus 3. Right. Perfect. Let's see what will be the answer. So we're going to have this now. Let's see. AC. We have 5 bracket 3 to the power of 1 minus 3, which becomes, let's see, 5 over 9, right? So my A is equals to 5 divided by 9. That's awesome. So now we're going to calculate the second term after this. So let me break this down for you. So the same with starting at T3 basically. Do you see it? Because n is 3 there. The bottom is always where you are starting. So obviously from T3, I'm going to go to T4 and so on, right? So I advise you to get T3 and T4, but T3 already got, it's your A for the sum, remember. So it does not necessarily mean that this is the first term of the pattern, right? So the examiner decided to start with term 3 going to infinity. So my term 3, because I substituted 3 there, I got this. So my term 3, it's 5 over 9. I need to get term 4 now, right? So to get term 4, I'm just going to replace that 3 by 4, which is 5 over 27, right? Perfect. And then from here, we can easily get what R is. Ne? T2 over T1, remember it's R, not T1. So R is not equals to T1 over T2. But in this case, because I have T4 and T3, I'm going to put 4 there and then 3 there. I hope that makes sense. So T4, it's 5 over 27 divided by 5 over 9. And then if you punch that in a calculator, it should give you 1 over 3. Okay, so that's my R, that's my A. Now I can easily substitute into the sum to infinity formula. 5 over 9. And then my 1, and then I'm minusing my R, which is 1 over 3, right? Now let's see what the answer is going to be. So I have bracket 5 over 9 bracket, then I have 1 minus 1 over 3. That gives me 5 over 6, right? So the answer to sum to infinity is 5 over 6. Some people prefer to round off to 2 decimal places, which is 0.83. Ne? Which is 0.83. And then that's finito about question 3. If you found this helpful, please subscribe to my channel and share with family and friends and advise them to do so too. I'll meet you in another session of Maths Fanatics. Thank you.